Hey there everybody, this is our second video in our series for Applied Math where we are looking at Chapter 3, Solving Acute Triangles. On our last video we derived the law and the formula that we called the Sine Law, and today we're going to use it to solve the examples in the book, in our notes package. So first of all, notice that the formula has kind of two different variations. I use the formula on the left for when solving for a side in a triangle, and I use the one on the right here when solving for an angle. And let's take a look at the first example. The first example has us looking to find the measure of side A. Well, first of all, you have to know that you measure or you label your sides according to the angles opposite them. So if this is angle A, across opposite is side A. That makes this side B because it's across an 88, and that makes this guy little side C. So I would like to find side A, so I'm going to go to my formula and use this ratio. So A over the sine of A. Now, I have three parts to this ratio. I never use all three at the same time. So I'm going to choose between using this part of the ratio or this part. Now, which part do I know both things? Well, I know angle B and I know side B. So I'm going to use this second part of the ratio, B over the sine of angle B. Because think about the way this formula looks. It's got four parts to it here. I need to know three of them to solve the fourth. And notice I've left the fourth in a nice convenient place right here on the top left. So A is what I'm looking for. I know angle A. I know angle A is 35 degrees. And B is 44 meters. And sine of angle B, I know angle B is 88 degrees. Now from here, I need to isolate side A. So I need to get rid of divide 35. So the way you get rid of divide is you multiply both sides of the equation by the sine of 35. It cancels on the left, and on the right, it's now part of this numerator. Some people just like to think that this crosses up and multiplies. We call it the cross multiply method, and if that helps you think about how it works, there's nothing wrong with that. And there we go. That's the calculation I need to do. Now, unfortunately, the only calculator I can kind of access here, if I can even get this to work. This didn't work last time I tried it. Let's see if I can make it work. There we go. I think you can see that. Okay, I'm going to clear that. And all right, first things first, let's make sure that we are in degrees. Hopefully on your own calculator you know how to do that. Yep, I'm in degrees, so I'm all good. And I'm going to enter in the sine of 35, and then hold on there a minute before I do this multiply. This calculator is the type that opens a bracket for me. Only kind of your fancier calculators do this, and it's a blessing and a curse. It's nice to open a bracket so you don't have to do it, but in this case I have to actually close it, or it's going to think I want the sine of whatever 35 times 44 is, which would be like a 1300 degree angle. So I want the sine of a 35 degree angle times 44, and then divided by the sine of 88. It actually doesn't matter since we're done the calculation if you close this last bracket or not. But when you hit enter, you're going to get the answer, which is 25.25. This is my rule, by the way. I don't care where you round it. If it doesn't say anything about where to round it wherever you like. So I'll just round it to one place. A is equal to 25.3 millimeters. But if a question says to the nearest tenth or to the nearest whole number, you have to do what it says or it's going to cost you half a mark. Same thing with units. If the question has units, the answer should have units. And there we go. That's how we use our new sine law. That's the easiest kind of sine law question. Finding a side when I know an angle across from a side. What if I want to find an angle? So the next example has us looking for angle C. So angle C, go back to the formula, is in this part here, but I kind of want it to be on top because I'm going to solve for it. So angle C is over here. So I'm going to use sine of angle C over C. So I get to use this part of the ratio. Now, what do I know? Well, I know that if this is angle C, this is side C, and if this is angle B, this is side B, and aha, I know an angle across from its side So that's the other piece of the ratio I'm going to work with. I'm not going to work with A because I don't know anything about it. And it's not asking me for it either. So I'm ready to go. Plug in what I know. I don't know angle C yet, but I know side C is 28. I know angle B is 62. And I know side B is 31. So cross and multiply. That 28 goes up to there. Goes to the numerator on the other side because you're multiplying it on both sides. And let's punch buttons. Okay, let me go back to that calculator. There we go. Clear the last thing. And 28 times. Now, if anybody has the kind of calculator where you have to put the number on the screen and then hit sign, make sure that you know how to do that. This type of calculator, you have to hit sign first, 62, and then close that bracket, divide by 31, and hit equals. And there we go. Now, hey, remember how SOHCAHTOA works? First of all, what's that number again? That's how good my memory is. 0.7975 and change. Blah, blah, blah. Could this possibly, I mean, look at it. Obviously, it's not a scale diagram. Nobody broke out a protractor to make this accurate. But could this be a 0.7, 0.8 degree angle when that's 62? I don't think so. Remember what the last step is? I'm going to just go off to the side for a sec. To me, I remember how to do this because to me this is algebra. I want to know angle C, and there's something in the way on the other side. Think about the way you do other algebra. If you were solving for x in this equation, this plus 2 is in the way. How do you get rid of it? Oh yeah, you minus 2 from both sides. And if you had 2x equals 8, how do you get rid of this times 2? You do the opposite of timesing. You divide on both sides, and you get 4. Here's a tougher one. How do you undo squaring? That's right. You square root both sides. And actually, you get a plus or minus. So I need to undo sign the same way that I undid adding by subtracting, and I undid multiplying by dividing, and I undid squaring by square rooting. So what's the opposite of sign? On every single calculator brand that I know of, it's called inverse sine. That's the symbol for it. It's not really an exponent. That's just a symbol. And I need to do that to this number. So how do I do that to that number? Well, what I do is, on every single calculator brand, it's always the same button as sine, but you get to it by hitting either shift or second function. And on the screen now it says that I want the inverse sine. Now I want to use that number that was my last calculation. So I have a button called answer. Most calculators have an answer button. If you have the kind of calculator where when you hit sine of 62, you have to put 62 then sine, then chances are you just hit inverse sine and hit equals, and boom, there's your answer. But on my calculator, I have to put a number in here for it to take the inverse sine of. So I'm going to go second function, answer, and then again, it doesn't matter if I close this bracket or not. And there it is. That ratio of 0.7975 came from and there I wasn't paying attention, 52.9 degree angle. And remember, degrees are a unit, so you have to put the units on it. So there's our second example. Okay, we've got a bunch more. This one is exactly like the first one. So what I want you to do is I want you to pause the video and try it yourself. Okay, so pause the video and give this one a try. How did it go? Did you label this as side A and this is side C? Did you recognize that if you're looking for side A, it's A over the sine of A equals C over the sine of C? And then plug in your numbers. A over the sine of 42 equals 8.3 over the sine of 55. Cross and multiply, and to get A all by itself, you're doing this. Ta-da! And then we punch buttons. So clear that. Sine of 42, close the bracket, times 8.3 divided by the sine of 55 equals. And the answer to this is I'll round it to 6.8 centimeters. How'd that go? All right, so that's our third example. Now remember the second example, we had to find an angle. And our fourth example is exactly like the second example. So again, pause this video, give this a try yourself, peek back to the second example if you have to, and see if you can get it. I'll pause for you. How did that go? Did you set this up by going, this has to be side P, and this has to be side Q? And at this point you might go, whoa, wait a minute. My formula has A, B's, and C's in it. What's with this P, Q, and R nonsense? Guess what? Look at the formula. It really doesn't matter what letters it is. Do you see kind of the pattern to the formula? The letters are the same top and bottom as long as I remember to label my triangle using my opposite side and angle rule, where I use the same letter for opposite sides and opposite angles, using the capital for angles and the lowercase for sides. So it doesn't matter to me that I switched from A, B, and C to P, Q, and R. It should work just fine. I am looking for angle Q, so I'm going to put sine of angle Q on top, which means I got to put little side Q on the bottom. Yes, that's how I make a Q. The kids in class made fun of it too. I'll make it there. Is that better? And then I have to ask myself, I say, self, what ratio am I going to use? Aha, I know angle P and I know side P. So it's going to be the sine of P over P. So I don't know Q yet. That's what I'm looking for. But I know side Q. And I know angle P is 80. And side P is 8. So cross and multiply. The sine of angle Q is 5 times the sine of 80 degrees over 8. Punch buttons. 5 times the sine of 80, close my bracket, divided by 8 equals 0.6155. And again, that's not the angle. That's the opposite over hypotenuse if it was in a right triangle of the angle. I know that seems kind of complicated, but that's the way you have to think about it. 6155, or actually you don't have to think about it at all. Once you get used to this, it's actually pretty mechanical. You just kind of remember how to do the steps. And remember that I'm doing now what's called inverse sine. I'm undoing sine to get my angle. So angle Q is, and again, I like to use my answer button. Come back, calculator. There you are. Inverse sine of my answer equals. So now, careful here. If I'm rounding this to the 10th place, that would be 37 point, but the 9 rounds up, so it'd be 38.0. And yes, if I said round to the nearest 10th, you have to write that 0, or technically you kind of didn't round it properly. All right. Next example is a little different. Check this out. I would like, once again, I'm back to A, B, and C, so hopefully that makes you happy. Once again, I would like, what would I like? I would like to figure out everything. Solve the triangle means I need to figure out how big side A is, how big side B is, and how big angle C is. I have to find the 3 missing things given the other 3 things. So, what can I do first? Well, you know what? I can't find these 2 sides first because, I mean, if I wanted to find side A, I'd need to know a side across from an angle, and I don't because I don't know this angle. If I wanted to find side B, again, I don't know any sides across from angles. So it appears like I might be stuck, and then I realize, wait a minute, I can figure out angle C. It's 180 degrees minus the other 2 angles. Because remember, all 3 angles in a triangle always have to add up to 180. So angle C is going to be 180 minus, let's open a bracket, 79 degrees plus 23.1 degrees, close my bracket, equals 77.9 degrees. Feel free to write that on your diagram now. Now we know it, we can use it. Because now I know an angle across from a side, and I'm off to the races. Now it doesn't matter which one you want to do first. Let's do A first. A over the sine of A equals C over the sine of C. So I'm going to put in my numbers. I don't know A yet, but I know the angle A is 23.1. And C is 59.6, right, the side up here. And sine of angle C is 77.9. There we go. So now I'm going to solve for A by, again, this number here is going to cross and multiply. So the sine of 23.1 times 59.6 all over the sine of 77.9. So side A, let's get the calculator back. Okay, you're in the way now. Okay, so clear. Sine of 23.1, don't forget to close the bracket, times 59.6 divided by the sine of 77.9, close my brackets, equals 23.91. I'll just round it to 23.9 meters, this one is. Okay, this is usually where somebody says, do we have to do sine law again? And I say, what do you mean do we have to do sine law again? Don't you want to know side B? We're not solved until we know side B. And then somebody will say, but yeah, but can't we use Pythagoras? Now that I know this side, I mean, I already found this angle, right? 77 point. I guess I can get the question mark out of there. I know that now. And I know this side now, 23.9. Can't I go a squared plus b squared equals c squared? And the answer is no, you can't. How come? Because Pythagoras only works with right triangles. This is an oblique triangle. I have no choice but to go back to sine law. And again, I'm going to use the c over sine c, because that was the first thing I figured out. I could use a over sine a if I wanted to. And then I'm going to plug in my numbers. So b over the sine of, what was angle b again? It's kind of off my screen, 79 equals c. Let's see, 59.6. Oh, I guess I could just look up there. Duh, sorry. Sine of 77.9. So yeah, I can't use Pythagoras. I have to use this. Pythagoras only works in right triangles. So side B is the sine of 79 times 59.6 all over the sine of 77.9. Let's figure that out. Oh, calculator. There you are. Clear that. Sine 79, close brackets, times 59.6 divided by the sine of 77.9 equals 59.8. Right? Is that what I said? Yeah, 59.8. What unit were we in again? Oh yeah, meters. And there we go. There's our first example where we had to solve everything in the triangle. We were given 3 pieces of information, and we had to find the other 3 pieces of information. Get used to that. You're going to see lots of problems like this. Okay. Speaking of which, here's another one. This one's actually, I think, easier than the last one because I can find angle F right away. Can I find angle E? No, because I don't know anything about side E down here. But I can find angle F because I know side F, and I know side G across from angle G. So the sine of F over F is equal to the sine of G over G. So the sine of angle F over 18 is equal to the sine of 45 over 14. And it's usually around here that sometimes people will start saying, couldn't I just skip this step and jump to this one? I mean, it always seems to be working the same way. And I'll say to those people, hey, if you're getting the right answer, I don't know that I need to see this step. If you want to jump right from the formula to here, I kind of do want to see the formula so that I can, if you get lost in the numbers, I can still give you those part marks because you have the right formula, you set it up right, you knew what you were doing, you just maybe punched buttons wrong. So if you want to skip this step, I don't mind. But this step, keep, and this step, keep. Okay, so the sine of angle F, and again, I punch buttons. At this point, you're probably getting really bored with watching me punch buttons. Or maybe you're not. Maybe you're starved for entertainment. How do I know? 18 times the sine of 45, close my bracket, divide by 14, equals 0.909. And again, I actually don't mind if you skip this step too, because I mean, this is again the way that it works every time that you're doing an angle solution problem. So I go back to my calculator and I say I'd like the second function inverse sine of that last answer equals 65.4 degrees. There we go. There's angle F. Now, do I need sine law to solve for angle E? Remember the last example, we couldn't use Pythagoras because it wasn't a right triangle, but the 180 rule, that there's 180 degrees in every triangle, works for every triangle. So no, for angle E, I don't need any fancy sine law. I just need 180 degrees minus the 45 plus 65.4. So that would be, back to you, Mr. Calculator. Now you're in my way over there. 180 minus, open a bracket, 45 plus 65.4, close my bracket, and it equals 69.6 degrees. And I'm not quite done yet. I'm also supposed to find side E, and now that I know angle E, I can set it up like so. Here, let me just split this so that you can see. There's first calculation, second calculation, and here's the third. E over the sine of angle E, and again, I'll go to the part that they gave me. G over the sine of G, but notice I had to flip it upside down because now I'm looking for a side, not an angle. So that's E over the sine of the angle we just found, 69.6, equals, and it was 14 over the sine of 45. And that's going to work out to cross multiply sine of 69.6 times 14 all over the sine of 45. And E is equal to, we punch buttons like trained monkey. So the sine of 69.6, close brackets, times 14, divide by the sine of 45 equals 18.6, and I forgot what unit it is, centimeters. And there we have it. That is the sine law. So try the homework questions from the blog yourself, and good luck.